All right, Advanced Math 8, here we go. We've got lesson 3.2.3. We're going to be multiplying polynomials and looking at the distributive property to do it. So first of all, the distributive property is when we are multiplying two different things. So we know in the distributive property that if I'm multiplying A times B plus C, A gets multiplied by B and A gets multiplied by C. So this would be A times B is AB, and then A times C is plus AC. So that's the general definition of the distributive property. But we can expand the distributive property to do it different ways. So here we go. On this one, okay, this is basically the distributive property, the very basic form of the distributive property. So we can do x times 2x, and that would be 2x squared. And then here, we'd get x times 1, which would be 1x, or just x. Okay, and we've already done these types of problems. We were just using the area model. So this is a different method for solving the same type of problems that we've done before. We are still kind of basically using the area model. We're just showing that there's a different method for doing this. Now on this one, so this is the last problem, 2x squared and then plus x, which we got the same answer. It's just a different way to do it. So this is using the distributive property instead. Now here I've got a binomial times a binomial. And the distributive property doesn't really cover this, but the basic tenets of the distributive property say every term from one thing is going to be multiplied by every term of another thing. So when I'm multiplying these two binomials, the x needs to get multiplied by both of these. And then the 3 also, we have to distribute it to both of these. So there's actually 4 different multiplications happening here. When I am multiplying a binomial times a binomial, every term from this binomial has to be multiplied by every term from this one. So there's going to be 4 different terms being multiplied. So let's just start down here. X times 2x would be 2x squared. X times 1 would be x. 3 times 2x would be 6x. And then 3 times 1 would be 3. We do have like terms here, so we have to combine those at the end of the problem. I would get 2x squared. X plus 6x is 7x because I have 1x plus 6x, and then plus 3. Now if you're looking at it, we are doing the area model. We're just not doing it with drawing the little square thing. For this one, x plus 3 and 2x plus 1. Here we've got 2x squared. Here we've got 6x. This one would be x, and this one would be 3. These two combine to give us this 7x. So we're doing the area model really, we're just doing it in a different format using what's called the distributive property. So this next one, distributive property, would say that we are supposed to multiply 2x times x and 2x times 5. So 2x times x is 2x squared. 2x times 5 is 10x. Next one, ooh, forgot the parenthesis there. I'll have to change that. So this is 2 times 3x minus 5. So 2 times 3x, 2 times negative 5. 2 times 3x is 6x. 2 times negative 5 is negative 10. Next one, we've got a trinomial. It still works the same way. Everything from this factor has to be multiplied by everything in this factor. So we're actually going to end up multiplying 3 different times. Y times 2x, y times y, and y times 3. So this one is 3 multiplications. Y times 2x is 2xy. Y times y is y squared. And y times 3 is 3y. Next one. Ooh, this is a bit of a sticky wicket. This one says 2x minus 1 squared. And you might be tempted to go, oh, 2x times 2x is 4x squared. negative 1 times negative 1 is positive 1. And you'd say, my answer is 4x squared plus 1. You're wrong. Because 2x minus 1 squared means 2x minus 1 times 2x minus 1. And if you wrote 4x squared plus 1, you are wrong because you're missing one of your terms. Let's prove it by going ahead and multiplying it all out. 2x has to be multiplied by 2x, and 2x has to be multiplied by negative 1. So here we've got 2x times 2x is 4x squared, and 2x times negative 1 is negative 2x. And then we'd have to multiply negative 1 times 2x and negative 1 times negative 1. Negative 1 times 2x is negative 2x, and negative 1 times negative 1 is positive 1. We have like terms. 4x squared minus 4x plus 1. So if you would just square both of these numbers, you'd be missing the middle term of 4x. And some of you are saying, wait a second, when we did exponents, you told us that we could go ahead and just square everything inside. That was only with monomials. The problems that we were doing before were problems like this. 3x squared to the second power. Yes, on this problem, I can just square 3 and get 9 and square x squared and get x to the fourth because it's a monomial. See, this has a negative in the middle. That's a binomial. This only works for monomials. Once you put a plus sign or a negative sign in between, you can't just square the individual elements. It doesn't work. So what we learned way back, I don't even know what unit it was anymore, probably unit 1. What we learned in unit 1, it only works for monomials. It does not work for binomials. All right, continuing on. 2x times 4x. Oh, there's only one multiplication here. That'd be 8x squared. This one, this is a little crazy. 2x has to be multiplied by x, 2x has to be multiplied by y, and 2x has to be multiplied by 2. 5 has to be multiplied by x, 5 has to be multiplied by y, and 5 needs to be multiplied by 2. So there's 6 different multiplications. And if you would have set up the area model, you would have had 6 little boxes, right? So the area model really just helps us keep track of everything. So here, 2x times x is 2x squared. 2x times y is 2xy. 2x times 2 is 4x. All right, so there's the first 3 multiplications. Now I'm going to do 5 times x, which is 5x. 5 times y, which is 5y. And 5 times 2, which is 10. We do have like terms right here. Those are the only like terms I have. So my final answer is 2x squared plus 2xy plus 9x plus 5y plus 10. All right, next one, 3-99. Are x plus 1, 7x plus 1, and 7x plus 1 times x plus 1 equivalent expressions? So would those be exactly the same? So here's what they've done is they have taken the x plus 1 and switched the order. Now, does it matter what order we multiply in? Well, let's think about this. Is 7 times 9 different from 9 times 7? No, they give you the same answer. So x plus 1 times 7x plus 1, it should be the same thing as 7x plus 1 times x plus 1. We should get the same answer. So in multiplication, it doesn't matter which one gets multiplied first. So they should be equivalent expressions. Next one, x minus 1 times 7x plus 1, and then 1 minus x times 7x plus 1. Should that give us a different expression? Well, there's only one thing we really need to look at. Look at 7 times 7x. That would give us 7x squared. Now over here, let's do this multiplication. Negative x times 7x gives us negative 7x squared. We can already see that these are not going to be the same term. So these two expressions, I don't even need to do the rest of it. I can tell right now they're not going to be the same, because this one would give me 7x squared, whereas this one would give me negative 7x squared. So this is not the same. Now, all right, what if I had x minus 1 times 7x minus 1 and then did 1 minus x and 1 minus 7x? So basically, what if I switch the signs of this one and switch the signs of that one? Would those be equivalent expressions? Well, we might have to multiply this all out first. So x times 7x is 7x squared. X times negative 1 is negative x. Negative 1 times 7x is negative 7x. And negative 1 times negative 1 is positive 1. So this one, if I combine my two like terms in here, it's 7x squared minus 8x plus 1. Over here, if I multiply 1 times 1, I get 1. 1 times negative 7x is negative 7x. Negative x times 1 is negative x. And negative x times 7x is positive 7x squared. Are they different? Nope. 7x squared, negative 7x and negative x is negative 8x. And then plus 1. They're exactly the same. All right, so this is a little bit of fun here. This is a area model problem where there are pieces that are missing, and we want to fill in the rest of it. So this area here is x times y. So this is x. I think this one must be y. Okay, this one is 3y. So if this is y, this has to be 3. So this would be x plus 3 times y. All right, next one. If this is x squared, then this one must be x, and this one must be x, because it'd be x times x equals x squared. Well, this one's 12x, so x times this must be 12. And then here, 12 times 5 would be 60. And then here, 5 times x would be 5x. Now it works out. All right, so here I've got negative 3y. And when I multiply, I get negative 3xy. So this must be x. Okay, here I've got negative 2. And then this one's negative 4x. So negative 2 times what equals negative 4x? This should be negative 2x. Because negative 2 times negative 2x, oh no, this should be positive 2x. Sorry. Negative 2 times 2x is negative 4x. So that means this box here is 2x times x, which is 2x squared. This box here would be negative 3y times negative 2, so that'd be positive 6y. Okay, so this is negative 2. Negative 2 times what equals negative 10? This should be positive 5, because negative 2 times 5 equals negative 10. And then our last box up here would be 5x. All right, so we got x squared here. This is x. This one must be x, because x times x is x squared. So at this point, if this is 6, there's a lot of different combinations that we could do at this point. What if this one was 1 and this is 6? Well, then this one would be 1x, and then this part up here would be 6x. So that could work. But I could have also made this 6 and 1 this direction, and it worked, because there was 2 blanks. There's a lot of different things we could have done. We could have also done 2 and 3, or 3 and 2, and those would all have worked. So that one had several solutions that you could have done to it. All right, that's all I got for you today. Keep on mathing.